This is mission 11, experiment number 7 with robot Spaten. I have a oscilloscope mounted on top of the robot right now. You can see right here it's just strapped on using a bungee cord. The oscilloscope is connected to the 5-volt power rail that is powering the compass. The purpose of this experiment is to determine what the voltage supply quality is, just to see whether or not a poor voltage supply might be responsible for the compass not responding after a certain amount of time during actual experiments. So this robot is going to be traversing the lollipop-shaped GPS motion script, and I'm going to have this dolly with a power supply attached to it using this extension cord, so that the oscilloscope can have some power. The robot is ready to go. So what I'm going to do now is I'm going to send it its motion script. The motion script I'm using is a much slower one. I'm going to change it to be going at 0.6 meters per second. Make sure that the file exists. Okay, 0.6 meters per second exists. So now I'm going to save the file, and then I'm going to launch the client. Alright, the motion script has been sent, and now the robot should be moving, but it's not. So let's see why it is not moving. It says invalid current location. What that means is the compass has stopped, the GPS has stopped working. And in fact, if you look at the GPS sensor here, it says there's a weak view of the sky. It might be because of all this equipment that's surrounding it right now. So I'm just going to hit this OK, and then hopefully this GPS will start working. So what I'm going to do is lift this GPS up out of this big mess here. So the GPS is still looking for satellites right now. And what I'm going to do is, oops, the cable is, I'll put it on the side like this. Maybe that would help find the GPS signal. So actually what I'm going to do is help it find the signal by removing it from the serial port there, holding it out here. You can see right now it's still trying to find the satellites. It says there's a weak signal. It needs a clear view of the sky. We've got one satellite locked. This is a recurring problem with these Garmin units. It probably is a recurring problem with all GPS units that are for civilian use. Alright, so we have an accuracy of 21 feet right now, and it's decreasing. So I'm going to now bring this back to the robot, and now I'm going to plug it back in. I'm actually going to first route this cable around the other way, so that hopefully it will be longer. Alright, so the GPS is now sitting on top of the oscilloscope, and it should be providing GPS data. You see the robot is now moving, and what I'm going to do is see if there's any information I can obtain about the quality of the... Okay, so here, this is actually very good. Oh, let me see. Alright, I just triggered the oscilloscope on a very, very high voltage here. I'm going to go ahead and stop the robot and print this to the screen. So you can see here that there's actually a huge amount of noise in the voltage supply. Now we are in the 100 nanosecond scale here. So let me see the x-axis. This is the x-axis has a each interval is 100 nanoseconds, So the width of this noise is about 250 nanoseconds worth of noise. And in terms of the y-axis, we have a 1 volt per division, and it is actually spanning a good 4 volts. And in fact, you can see the measurement here. The channel 1 right here has a peak-to-peak voltage 4.84 volts. I suspect that this noise here may be the reason why the compass fails while we're running experiments. So what I'm doing right now is I'm capturing this data to a USB drive, and I'll analyze this offline. Notice that I'm using my foot right here to lift the robot up and that the wheel is still spinning. What that means is that the GPS and compass data is still coming in, so we can still continue this experiment. Alright, we're still waiting for the data to be saved to the USB drive. Alright, the data has been saved, so what I'm going to do now is I'm going to continue the trigger. Alright, the trigger is now armed, and I'm going to let this robot run. And while it's running, I'm going to push this cart with it. Notice that the speed is at a slow 0.6 meters per second. Okay, actually I'm going to stop it again because I've captured another extreme pulse here. Right here you can see that. This is in the voltage supply. I'm going to go ahead and save that to USB drive again. So this one here is again about 250 nanoseconds wide. If you can see that on the video right here. This is the voltage over time. Each division is 100 nanoseconds. Each division of the y-axis is 1 volt. So again, this is about 250 nanoseconds, and plus or minus, it looks like some 4 volt, I'm sorry, plus or minus 2 volts, making a peak-to-peak of 4 volts. As soon as it's done saving to USB, the data to USB, I should be able to see what the peak-to-peak voltage is as measured by the oscilloscope. There it is. And let me see if I can zoom in here. You can see here the peak-to-peak is 5.36 volts. So this is a huge amount of noise that is being fed into the compass, and it's a potential reason why the compass is failing while we're running motion script waypoint experiments. So okay, so I'm going to go ahead and what I'm going to do now is I'm going to lower the since I already have 2 of these captured, I'm going to lower the trigger level even more so that it's exactly 2 volts. Okay, so now I've lowered the trigger threshold. Oh, actually it was just triggered. Let me see. I'm going to adjust this Y scale, okay. So I've zoomed out a little bit now. Now it's 100 microseconds per division. And I'm gonna set the trigger, so the y-axis is still 1 volt per division. I'm going to set it to be about 2 volts of the trigger threshold. 2 volts trigger threshold. So now the voltage threshold for triggering is at 2 volts, and we're going to now allow the robot to run. So I've just set the robot on the ground. Alright, I believe it's reached its second waypoint here. I'm going to go ahead and lift it up again as I look at this data here it was just acquired. Oops. Alright, so it looks like the voltage, I've zoomed out a little bit now. Now it's at 25 microseconds. And let's see. I see some noise, but I've zoomed in so far that it's only showing up as like a single pixel. So I'm going to zoom in a little bit more. Okay, now we're at 1 microsecond scale. And I'm going to set the triggering about 2 volts. I've armed the timer. I've armed the trigger. And I'm going to let the robot go now. I just captured one there. I'm going to go ahead and bring this power supply closer. Okay, so I did capture one right here. I'm going to go ahead and try to capture another one. You can see here that the peak to peak here, let's see, is about 3.08 volts, and it lasts for about 1 microsecond. Alright, I'm going to go ahead and turn off the video now so I can focus a little bit more on taking oscilloscope measurements. This is mission 11. I believe it's experiment number 7.